In this question, it is given that following forces starts acting on a particle at the resultant at origin of coordinate system simultaneously F1, F2, F3 and F4. Then the particle will move. So RM is to find out in which direction this particle is going to move. So if you are going to add all these forces, let's say F1 vector, which is minus 2 I cap and minus 5 J cap and plus K cap, and the other vector take it as F2 vector, which is equal to 5 I cap plus 8 J cap plus 6 K cap, and our F3 vector, which is equal to minus 3 I cap plus 4 J cap and minus 7 K cap, and the value of F4 vector is nothing but 2 I cap minus 3 J cap minus 2 K cap. Then the particle will move in. So if you are adding all these forces, so let's see what we are going to get. In the first part, it is minus 4 and plus 5, we are going to get plus 1, and plus 1 and minus 3, we are going to get minus 2, and minus 2 and plus 2, we are going to get as 0. So its x component is 0. Same as like that, if you are observing its y component, this is minus 5 and plus 8 will get as plus 3. Plus 3 and plus 4 will get as nothing but plus 7. 7 minus 3 will get as 4. So we can write this as plus 4 J cap. And the other component, Z component, is plus 5 and plus 6. That is nothing but plus 11. And 11 minus 7, we know that it is equal to nothing but plus 4. Plus 4 and minus 2, we can take it as nothing but minus plus 2. So the resultant vector is nothing but 4 J cap and plus 2 K cap. So this resultant vector is not having any x component, or it is having y component as well as z component. So the particle is going to move in YZ plane. So in option, suppose if you are getting only x component, then the particle will move along x. Only y, it will move along y. Only z, it will move along z. If it is having x and y component, then it is an xy plane. If it is having y and z component, then it is going to move in YZ plane. And if it is having x and z component, then it is going to move in XZ plane.